In this world, there is an abundance of copper. But, the question is, how copper works as an electrical and thermal conductor.
Copper is one of those materials we use all day long in all kinds of ways, without ever really noticing and thinking about it. Every time we switch on something electrical, like a vacuum cleaner or a washing machine, every time we watch television, every time we make a telephone call, we're all using copper. It's one of the oldest metals in common use, dating back to 10,000 years ago. Copper is one of the few metals that can occur in nature and in a directly usable metallic form. This led to very early human use in several regions. From 8,000 years ago before century, thousands of years later, it was the first metal to be smelted from sulfide ores, the first metal to be cast into shape in a mold, and the first metal to be purposefully alloyed with another metal, tin, to create bronze. Copper is a chemical element with the symbol Cu, which is derived from the Latin cuprum and has the atomic number 29. It is a relatively soft, malleable, and ductile metal with very high thermal and electrical conductivity. A freshly exposed surface of pure copper has a pinkish-orange color, which we often say the copper is brown. It's roughly the 25th most abundant chemical element in Earth crust and is found throughout the world. Why copper has been widely used since it was found back then until nowadays. Today, we're going to talk about the electrical and thermal conductivity of copper.
I am ZAWAWAI, and today I will share with you about copper and conduct electricity. So firstly, what makes copper as an electricity conductor? So firstly, because copper contains free-moving electron or free-moving ion. So where this free-moving ion come? Okay, as all we all know, that copper have valence electronic configuration, which is 4s1. So that means there are one electron located at 4s orbital. So copper has one valence electron. So in order for copper to reach a stable octet electron configuration, so copper need to remove one electron. Okay, so the one electron will be the free moving ion. Okay, so how copper can work as electricity conductor? So okay, as we can see in electric circle, so we have one unit of dry cell. So okay, the electron from the battery is transferred through the wire and transferred to the copper strip. Okay, so when the electron reach the copper strip, the electron will make the free moving ion in copper strip to become excited. And when the free moving ion become excited, they will jump from one positive copper ion to another positive copper ion. Then the electron will flow and keep flow until they reach back to the battery. This is because the electron have a negatively charged and they will attracted to the positive terminal of the battery. Okay, so how can we prove that there are electron movement in this circuit? So we can prove that by So when in the electron moving, they also transfer energy. So when the energy so we see the copper string. So when the ion is collide with each other, so they will make heat energy. So the copper string will become hot. So this shows that energy is transferred. So that's how copper can conduct electricity. It's because of the free moving electron. That's why we balance the electron copper. So that's all from me. So now I will pass to my other members to continue with application of this theory in our daily life.
Hi, my name is ALLIEYSA and I will talk about copper as a good electrical conductivity. The example of copper as a good electrical conductivity is electromagnet. Copper is used in electromagnet because it has a low electrical resistance. This means that it is easy for the current to flow through it. Also, copper wire can be easily shaped to make a coil. How it works? All electromagnets work on the principle that an electric current in a wire produces a magnetic field. Simply coil a length of wire round a piece of iron, such as a long iron nail, and pass an electric current through the wire. When the current flows, a magnetic field is created and the iron becomes magnetized. The use of electromagnetic are electric bells, strap yard crane, and locks. Second, we have motors. The copper rotor bars and end rings in the motor reduce electrical losses, leading to a smaller and more efficient motor. How motors works? An induction motor or a synchronous motor is an AC electric motor in which the electric current in the rotor needed to produce torque is obtained by electromagnetic induction from the magnetic field of the stator winding. An induction motor can therefore be made without electrical connections to the rotor. We use motor in pumps, domestic appliances like washing machine, and computer such as disk driver and fans. Lastly, we have transformer. Why we use copper in transformer? Copper is the logical choice for medium to large transformers. It keeps the size of completed unit small enough to transport easily. The smaller size of copper transformers saves core steel, as well as structural elements including the tank, oil, cooling equipment and other accessories. Manufacturing savings and the fact that coils and conductor comprise less than 10% of the cost of the finished transformers minimize the effect of price differences between copper and aluminium. Copper is stronger than aluminium and therefore withstands stresses imposed by fault current better than aluminium. Because the coil is stronger and less likely to deform, transformer life is extended and life cycle maintenance costs are reduced. Copper's better connectivity means that connection inside the unit stay tight, reducing maintenance and prolonging life. Where transformer is used? We use transformers in electricity substation and power station. That is all from me. I will pass the turn to QISTHINA, who will talk about how copper conduct heat. Stay tuned. Bye.
Okay, now I will explain about how copper conduct heat. Heat conductivity is a measure of the ability of a material to transfer heat within itself. So what is the relationship between heat conductivity and copper? As we all know, copper is a good conductor of heat. This means that if you heat one end of a piece of copper, the other end will quickly reach the same temperature. Copper allows heat to pass through it quickly. Most metals are pretty good conductors. However, apart from silver, copper is the best, as copper has one of the highest thermal conductivity in rank. So, how can copper conduct heat? Copper is made from a lattice of ions with free electrons. When the ions vibrate and the electrons will move through the copper rather like a gas. This transfer occurs at the molecular level from one body to another when heat energy is absorbed by a surface and causes the molecules of the surface to move more quickly. In the process, they will bump into the others and transfer the energy to them. This process continues as long as heat is still being added. So, in copper, a free electron will collide with an ion at the hot end and gains kinetic energy which makes it speeds up. The free electron will move to the cold end and it will collide with a cold ion, making the previously cold ion vibrate more. This heats up the cold end. In this way, energy is transferred through copper from hot to cold. In short, copper can conduct heat because the electrons in copper are delocalized electrons and are free moving electrons. So when they gain energy from heat, they will vibrate more quickly and move around freely. This means that they can pass on the energy more quickly. For instance, copper is good at conducting both heat and electricity, hence why copper wires are used so widely in the manufacture of electronics.
Since copper conducts heat well, it's also commonly used in cooking utensils such as the copper saucepan. Expert chefs have noted for a long time by using copper cookware, any meal can be prepared in a perfect and gentle way. They are the best pots and pans for cooking and roasting. This is particularly due to the fact that copper has excellent material properties, which is copper is a perfect heat conductor. The heat will evenly be spread over the cookware and dispensed accurately. Do you know that copper is one of the most commonly used material for water pipes in the world? Copper is durable and recyclable, which means that using copper piping for water pipes will not deplete copper supplies and has lower impact on the environment than some other choices, like the PVC. Despite the initial cost of copper water pipes may be higher, its durability makes it an excellent long-term value. Why copper has been widely used in water piping? Copper pipe conducts heat well. This is the reason. So the pipes get warm during exposure to hot water and able to stay warm. This helps keep hot water at a consistent temperature as it travels through the house. Copper's conductivity makes it the perfect choice for radiant heating systems that pump hot water through the floors to heat a room. Next is the heat sinks. Some of you may not be familiar to this. A heatsink is a component that transfers the heat flow away from a hot device to cool down the processor. It is commonly worked with a fan inside a computer, moving air across the heatsink and out the computer. This process is known as the thermal conductivity, which is how heatsinks transfer heat away from the computer processor. One of the best and most common materials used to make heatsinks definitely is the copper. Copper has a very high thermal conductivity. It is, however, heavier than the aluminium and maybe more expensive, but for operating systems that require an extensive amount of heat dissipation, copper is definitely the best choice. In summary, the qualities of copper that have made it the material of choice for a variety of domestic, industrial, and high technology applications have resulted in steady rise in global copper consumption. Do you know that copper is also necessary for human health? The best sources of dietary copper include seafood, organ meats, whole grains, nuts, raisins, legumes, and chocolate. That's why we have to make good use of this resource. That's all from us, Group 4 from K15, and thank you.